All right, quick second to review what we've seen so far before we move into dilations today. So the algebraic mappings that you guys have been kind of playing around with and trying to figure out on your own. Just a quick rundown of what those are for a lot of these transformations. So kind of pre-quiz stuff here with the reflections, but remember x, y, what we did, we flipped the y coordinate. If we flipped over the y-axis, we switched the x-axis. When we reflected over the line y equals x, remember that's where the points just switch places. And then if we flipped over the line y equals negative x, remember that's the diagonal line this way versus the line y equals x, remember was the line that went that way. So anyway, back to it. Not only do you switch the coordinates, but you also switch the signs. So for the rotations, which you guys kind of picked through a couple days ago, the first thing to realize with both 90 clockwise and 90 counterclockwise, the x and the y you should have noticed switch places. But not only that, there's also something happening in terms of the the negatives. And the real easy way to kind of come up with this is if you think, so clockwise, if you'll draw a clockwise arrow on top, that'll actually point to which one should be negative. So in this case, that's y, negative x. So if you draw a counterclockwise arrow for 90 degrees counterclockwise, it points to the y, which tells you that it's negative y comma x. And then one that a lot of you guys recognized on your own pretty quickly was 180 degrees, and the point didn't change positions, but you switched the sign on x and y. So moving forward to what we're going to talk about today with dilations. So a dilation is basically going to make things bigger or smaller. So one of the big terms for us in here is what's called a scale factor. And that's just going to basically tell us how much bigger or smaller to make it. So let's say that we start this example. We've got a at -1, -1, b is at 0, 2, and c is at 1, -2. And we're asked to make this thing a different size using a scale factor of 3. So in other words, we're going to triple the size of it. Scale factor tells us make it 3 times bigger. In this particular case, in example 2, it says scale factor, so we're going to multiply by 1/2. Or, another way to look at this, you could also divide by 2. So we'll get down to example 2 in just a minute, but let's take a look back at example 1. So in other words, from a being -1, -1, b being 0, 2, and c being 1, -2, since the scale factor is times 3, we're going to take each one of those points, and we're just going to multiply everything by 3. So -1, -1 becomes -3, -3. So a prime gets a little bit further from the origin. B prime, 0 times 3 is 0, 2 times 3 is 6. So we're now at 0, 6. And then for C prime, becomes 3, -6. So 1, 2, 3, 1, 2, 3, 4, 5, 6. So now we got C prime. You can see it makes it a much bigger triangle. In fact, the red one is going to be 3 times bigger. And as these things get bigger, one of the big terms to kind of think about, a term that will get thrown around a lot, this is an enlargement. And as these things get smaller, right, we're dividing by 2, this is what's called a reduction. So if you hear me throw out those terms, we can kind of all stay on the same page. So if drawing the picture helps, then go for it. But sometimes these dilations actually might be a little bit easier just to kind of do the math very quickly. So E being at 4, 2, F being at 1, 8, and G being at 6, 4, you're literally going to take all those points, cut them in half, because that's what we're told to do. Use a scale factor of 1/2. So E prime is now 2, 1. F prime is now 0.58. And G prime is now at 3, 2. So it took that original triangle and we should have made it smaller. One of the real-world applications that you would see this in is photography. Some of you might be into photography or it interests you. So a lot of times what you have this negative that's, 2 by 1. So we went from 2 by 1 up to 4 by 2. So the question here is, what's the scale factor? Well, 1, it did get bigger, so we know that the scale factor is going to be a larger number, if you will, a non-fractional number. And this one's actually pretty easy to spot from 2 by 1 to 4 by 2. Well, that just doubled, so our scale factor is 2. Right? So sometimes you've got to kind of figure out what is the scale factor. Sometimes I'll just say, hey, we're going to use a scale factor of 24. So in other words, we're going to take this 2 by 1 and we're going to multiply it by 24. So you take each of those pieces. So 2 times 24 is 48. And then 1 times 24 is 24. So we got our new poster size version of this picture that's now 48 by 24. So, like I said, sometimes, just drawing these figures and doubling the points, not really the difficult part of this. The part that's probably the most tricky, if you will, for folks is actually coming up with the scale factor, right? When you're given the points, you have to give the scale factor. So the trick for us is we're going to take something from the image, we're going to divide by the corresponding piece of the pre-image. So remind yourselves, right, that's kind of the formula you're going to use. So we have to remind ourselves very quickly, here's the pre-image, right? Because it doesn't have any of the primes. And here are all of our images. Well, to use that formula, the big trick here is make sure we use the right piece at the right time. So for example, 0, 0, and 0, 0 is not really going to be very helpful. It didn't move. But if you look at 0, 4, we got some movement up to 0, 10. Sometimes you can kind of figure these out on your own, but from 4 to 10, it's obviously gotten bigger. So we have an enlargement. Right? So what scale factor was used? Sometimes these are pretty easy to spot, like it'll just double or triple, and that's something that you guys will probably be pretty quick to pick up on when it's those easier ones. But here's one's a little bit trickier, so we'll use our formula. Right? So the 0 is not really helpful, but we'll take that 10 from the image, and we'll divide by the corresponding piece, which is the 4 from the pre-image. And 10 over 4 simplifies to 5 over 2, which would be a scale factor of 2.5. Right? If you'll notice, we could pick really any point as long as we have valuable pieces of information. So for example, we could do the 15, go to the corresponding part in E, which is 6, and 15 over 6 again is 5 over 2, which is 2.5. So what you should notice here, regardless of which piece that you use, as long as you use the right corresponding part, the scale factor should remain the same. All right, so another quick example, you look at number 7. Again, the 0 is not really helpful, but we'll look at T. So T starts at 0, negative 3, and then we went from 0, negative 3 to 0, negative 1. So in terms of multiplying and dividing, here we actually had to divide by 3. But 3 isn't the scale factor, because the scale factor is what we would multiply by. So some of us might pick that up pretty quick. Well, dividing by 3 is the same thing as multiplying by 1/3, but I can still go up here to this formula that I gave you guys earlier. So let's take a piece from the image. Well, the only valuable piece is negative 1. And then take that corresponding part from the pre-image, a negative 3. And what we should see is negative over negative is positive, so my scale factor is 1/3. So here we have a reduction. It's getting smaller. Another practical application, if there's any cooks out there, to think about, let's say that it takes 4 cups of flour, 1 cup of sugar, 3 tablespoons of oil in this recipe for 8 people, but we got to cook for 48. So in other words, we need, right? 8 times 6 is 48. So we need to take those 4 cups of flour, 1 cup of sugar, 3 tablespoons of oil. We need to multiply everything, make it 6 times bigger. So math here, not that difficult. So we now need 24 cups of flour, 6 cups of sugar, and 18 teaspoons of oil. Okay, so there's another practical application of some of this dilation stuff. So in this particular example, probably a little bit too tight to try to squeeze this picture in because these points are so close together. So we'll just make sure we're good here in terms of using the scale factor. So we're going to use a scale factor of 1/2. Centered at 0, 0 just means that we're not going to have to do anything too crazy. So P started at negative 2, 2, Q at 2, 2, and R at 0, negative 2. So all we want to do, since the scale factor is 1/2, we're just going to cut everything in half. So P prime is now negative 1, 1. Q prime is 1, 1. And R prime is 0, negative 1. I'm not trying to flip negatives or anything like that. You're literally just multiplying through by the scale factor. And then the the other example that you guys could end up with is here's the image, here's the pre-image. Go ahead and take a moment to figure out what the actual scale factor is. All right, so remember our trick here. I'm going to do the image divided by the corresponding piece of the pre-image. So biggest way to find the image versus the pre-image is find the primes. We'll just pick B prime, which means we need to look back at B. And so pick one of those pieces. Just to avoid the negatives, I'll use the first piece. So in the image we have 12, and then in the pre-image we have 6. So 12 divided by 6 is 2. And then if you look closely, right, you look at A, we went from 3-1 up to 6-2. Well, really that's doubling, and some of you guys might be able to figure that out very quickly just looking at it.